Graphic Dreamers, welcome and thank you for following us and coming back. This is actually a seventh review, and I'm very excited because for this one we're going to do something very different. This is not a commercial product per se, and it's called the North Star. So, the North Star is actually an open source project. It was initiated by Leap Motion, and Leap Motion created this concept of augmented reality headset that would use their Leap Motion controller to see the hands and control with hands. And they eventually open sourced it. They created a Git repo, uploaded all the schematic to be able to print it out into a 3D printer, and you can create it. And then anyone can build one. So this is the one I built with Ben Sachs from Perstoscope, and we got that together. And I would like to show you a little bit how this works and the possibilities, and also why would you ever do that? Okay, so let's get started. So first, I want to start with a little bit of how it works. How can you do it? How can you do it yourself? And it's very simple. You would go on the website, and there is a Leap Motion website. If you go on the developer site for Leap Motion, you'll get access to some of that info. So let me show you a little bit some of those sites and what you can find on those and where the value is on creating that. So let's get started. So yeah, if you go on the developer site, or you just Google Project North Star, Leap Motion, or just Ultraleap, and you'll arrive to the website that explains a little bit how it works and what you can expect there. You can download the files, and if you download the files, I can't because this is locked to one. You'll download the file, you have a bunch of documents you can print out, and that you can also put into your printer to print out. So there's a lot of version now of the Project North Star, so it gets a little bit confusing, and it's easy to get lost. So those typically are the different parts you can find, and you'll have to print. And there's a few elements you will not be able to print, and those elements are pretty complex actually. So I'm gonna skip here and stop recording here, and I'll record after. There we go. So the elements that you cannot print is one, the Leap Motion. You have to buy one. It goes with it's a controller. It's not very expensive, but still. That glass, those are special, and you need to get somebody to do them for them. And the displays, even if you could find the displays, the one that you can find on the market today for the North Star are pretty well designed, and they work really well with the device. There's also I didn't put it there, but they have like a little controller for the display that appears here, and it's really thin, really easy. And this is the power that's the power for the display on the USB cable. So let me show you on the site. I'm gonna restart the recording. There we go. So the website where you can actually buy those elements that you cannot print, they can also print it for you. So I think there's a few people that does it, but we did it with those guys, and we purchased the initial kit, which includes the cables. They include some of the art stuff that we cannot print. So those parts here, a lot of the screws, and also a lot of different type of screws. It includes the display, comes with the display, and it comes with that glass to do the reflection. And that's the key element that they provide, and for $300. So we bought that, and if you want more, you can get the full kit. And I think if you get it printed and all assembled and all calibrated, it's going to cost you around $700 to get the calibration and everything working. So that's how you get started with this headset. Now let's go a little bit on describing it a little bit more, because it's a very strange device. So here you can see we have two displays. So most of headsets like the Rhino X or like the Meta are using one big display on the top that reflects on the screen, like the Mira from Mira Lab. But this one has two small displays. and you see from inside here. So let me put the headset on. That would be where I would see. So my eyes are here, displays are on my side of my eyes, and they reflect into this this reflection screen. And the field of view is amazing. It's really big. The displays are very bright, so it works really well. So those are the reflection you get here and here from there. Now you have like this rail here to adjust, so you can get this closer or further from you. That comes also with the kit, this little tight here, which is convenient to tighten it up. The foam also comes with the kit. So basically what we had to do is just print all those purple things you see. We print them out, and then it took us probably a little bit less than a day to put everything together. And that was pretty well done, actually. What you need to make sure you're not confused in is the versions, because they keep having new versions of it, and sometimes the documentation doesn't match the version you just printed. So you need to make sure you have the proper version, and you're printing all the parts from one version. The device itself, in terms of the wear, so far it's okay. You have it's well done. So the headset holds a little bit like the old HoloLens on this kind of like outside of the parts. So you have this like cushion here that goes on the forehead, and that goes on the back of your head. And then you can slide on the side here to move it closer to eyes or further to your eyes. One thing I want to mention also is that there is two types of display. Two types of adjustments. So we have two parts for this here, and one is for the near, one is for the far. So the adjustments for the eye calibration is different if you have a near or a far. So the parts here are very different. One is more oriented, and so it's much thinner, and then it will adjust that displays on your eyes to be able to work with elements that are far away from you, further than your arm length. As we wanted to test with the leap motion and the hand tracking, we're really interested in to see the quality of the hand tracking and all the experimentation we could do with the hand gestures. We kept the one that were close. Okay, so now I'm going to go into the capabilities of it. So to be honest, it's quite limited, and as you can see, it's a tethered device. It's not like other devices that have everything embedded. So you have a fair amount of cable coming out, and I'm missing one cable. Right now I have the leap motion. It sees my hand. Basically, I'm in 3 DOF, and if I want 6 DOF, I need to add in one more device. And we didn't have time to print the mount for it, but I have a structure core here. You could do it also with the Intel 435 Intel IntelliSense, and with the IntelliSense you put it on top, or the structure core you put it on top. And with that, you're able to bring into your device 6 degrees of freedom, where you will move around and things will seem more stable, and you can still attract things, put them on the table, all those type of elements. So with that, you accumulate all the device and the sensors you need to actually create a good AR device. Without that, it's kind of limited, but still, it's pretty good. So that would add one more 4th cable out of this. Probably I can find a way to make that cleaner, but for now, this is what we have now. And the really cool thing, and I'm going to go a little bit after into the development kit, but the really cool thing with this device is that you are actually creating your own. Basically, you can experiment with it. If that depth of the field of view or that depth doesn't work for me, I can adjust it. I can recreate it. If that forehead and this element doesn't exactly match me, I can just make a modification and reprint the part and make it work for me. Like some people have created like little inserts to be able to put that, and on top of this, and that's part of the printing. It'll be part probably of the next version. But for now, there's improvement. So they have a very active Slack channel. Discourse, I think. Excuse me, not the Slack. Discourse, I think. They have a very active Discourse channel where you can discuss, give feedbacks, and some people get their modification and share them. And eventually, some of those will be part of the next release of the device in terms of a blueprint. So, in terms of let's go into the software now. I'm going to go in detail a little bit more what's happening in the SDK and the development kit and how all that part works. So, I'm going to put it on. It will be easier for me at that point, maybe not with the lights. Let's see. So it sits on my forehead. The device is fairly heavy. I'm gonna move it closer to me. For some reason, I like it when it's really close. We can tie that a little bit more. Okay, here we go. Okay, so I'm going to switch to Unity. I'm going to show you some of the elements there. So first, let me start the recording. So I don't have the, like on a lot of those devices, I could show you guys a compositing of what I see in the real world. In this case here, I didn't have time to figure this out and set it up. So what I'll show you is the Unity setup that I have here. So I'm going to run the app, and hopefully we'll record properly the right window, because that's a little bit confusing sometimes. I hope it's not raining. I hear some noise like if it's raining. So hopefully here you're seeing, oh yeah, you're seeing it. You're seeing my hands, and I'm recording that. So that's what I'm seeing into the display. So it's projecting on me all the hands and the hand gestures that I'm doing here. So that's my hands, and I could do interactions and touch and modify that and get all those features working into my my field of view and things. So I see through right now. I see them. Actually, I didn't calibrate it well, as you can see. So the actual thing's above my hands, but when you calibrate it properly, it looks pretty close to your hands, and it feels pretty good in terms of the visuals and the field of view. Because of those big things on the side, the field of view is not really an issue, because anymore I cannot see on the left and right beyond this little space I have at the center to see what I want to see in the center. And oh, here they are. That's pretty cool. And that's the demo I had time to build and put together for you guys. So let me stop this, and I'm going to restart also again the recording without this display, so I'm sure that I can show the Unity device here. What I want to show with Unity, and it's really raining outside. It is raining outside, so it's going to be interesting. So let me restart the recording. I'm going to put my side here. There we go. So there's an APK you can install, and there is a fair amount of elements you can get from there. So it's all from Leapmotion. A lot of them. There's a Leapmotion controller you need to install. So yeah, I did that a few days ago. So now it's a little bit in my back of my mind. So here's that's the Leapmotion. So, and in the Leapmotion, there's a North Star element here, and there's some elements and source code for that. Let me move that up. There's also a sample scene, and I think that's the one I'm running on. I think I made a copy of it because I was playing around with it. But there's this sample scene, and I'll go over the different elements in that sample scene for you to get a sense of that SDK. So there's these tools. So yeah, everything is in the AR camera rig basically, because that's all right now that's all the has. I don't have the structure or the R35 for the 6 degree freedom. So the AR camera rig is here on the right. So let me show you a little bit the SDK. So you install the Leapmotion software development kit for Unity. You have a section in there that you have that will work with the North Star. So you have a sample scene, and that's the sample scene that I have open here. And within that sample scene, you have those tools there for the window managers. Those are really cool. So basically, that's what opens like this game thing that I can put into the second screen. Because I have an extended screen here, that's what displays in here. So I can put then that window controller into the extended screen, and that's where I can see my hands working around that. There's a fair amount of screen to work, and you can be adjusting. This is my IPD, so that works really well for me. I didn't play with that exactly yet. So yeah, then you have all you need to be able to make it work. The left eye, the different camera systems, um, and eventually, because it's a leap motion, you'll have the end controllers that works with it, and that's similar to the end that you have for leap motion. So if you're familiar with the leap motion SDK, those will look very, very familiar to you. So basically, the main thing is this AR camera here that's plugged in. There's a little element for leap motion. It's like the Orion version of it, so where it's reversed. It's like the VR, for working in VR. And yeah, for sure, the interaction manager. So not too much here to complexity. One thing I've not done on it, and we still have to do with Ben, is the calibration. So yeah, as you can see, the SDK is fairly standard. There's an additional app outside of the SDK for doing the calibration that we've not yet used. So far, it's been like playing around with on looking for too much precision, and the optic looks pretty good out of the box. So we were pretty happy with that. The calibration part requires 2 additional cameras that we still need to order. So we'll get into that after. So in terms of conclusion here, I don't want to spend too much on that. So yeah, exactly. So those are the SDK, fairly standard. You have the camera systems, and you have the leap motion controller. I didn't have the SDK for the structure or the R35, and I'll get that on probably the next version when we get more progress on this. The next step for us with this device is to calibrate it. And on the GitHub repository, I think I showed the GitHub repository, which is one of the best part of it. The GitHub repository, you'll get a fair amount of information, and you'll get all the updates. Like I said, there's this discourse or Slack, I forgot exactly which one, but there's a place where you can connect with the community on this. And they're very active, and there's a lot of new stuff and happening and people experimenting things, which is amazing because that's the part of an open source project. So in terms of the software, there's exactly, North Star Calibrator there. That North Star Calibrator here, that's what you need also to get the calibration going. And there's a fair amount of things going in there to create the calibration. So you have to print a system, and you have to run through 2 different cameras. So we're gonna work on that next and see where that takes us in terms of the accuracy of the getting the ends perfectly matching and all those elements, and hopefully be able to get some more concept of depth and 6 degree of freedom working. So that's exciting, and let's do a little bit of conclusion on that part. The idea is just awesome. The idea that there is on the market today an open source augmented reality headset, and that's pretty good, I would say, in terms of what we would expect and the promise of AR in general. You have the hand tracking, you have the 6 degree of freedom, good quality display. I cannot confirm all the perspective and the quality of those optics yet because we didn't finish the calibration, so I wouldn't talk about it. But at least it feels like it's working really well, and you can put it on your head. There's a decent amount of comfort that you can actually personalize because it's your headset, it's open source. You can personalize it. So for that, I'm really impressed, and I'm very excited about it. And there's a few companies here that are in LA and San Francisco that are actually producing a lot of those, like Solaris, and those are very active in that sense, and then the community around it. So we're excited about it, and I really like and want to see where that's going to go. I think that today it's mainly for experimentation, and if you want to start experimenting or designing your own AR headset and thinking about it, this is a great way of starting. If you want to get into hardware, in terms of practical use for us, it will be mainly about experimenting for user experience design in terms of interactions and UI, using the wider field of view and the hand tracking. It will be a more abstract version of it than what we have on the HoloLens, but also a good playground for us to play around with those technology and getting some good user experience design and new concept of user interaction in AR. So for that, it's going to be useful for us, and we're excited about that part and to be able to experiment with it and make the adjustments we need. Like if we have an HoloLens, we cannot get an adjustment if we need an adjustment that will work better for us. With this one, we can. So that's the exciting part. The draw part of it is that it's still really complex. AR is not something simple. It's hard and complex technology that requires a fair amount of CPU. My computer is really like overheating right now. No, not really. I'm kidding. But it is a fair amount of CPU it requires, and all those cables. So this is not going to be something consumer anytime soon. But everything that's about education, everything that's about experimenting and learning and making progress, we may eventually get there to somewhere where we can get that device into something that's close to put in somebody's hands. But at least for the learning part, it's awesome, and that there's a community around it now already that's improving and getting improvement in it. This shows the power of the open source, and I really believe in it. So I think that this device will evolve way faster than we think, and maybe eventually we'll get to consumer. But at least we will be able to use that to cover some very, very specific use case that any other device cannot by creating a very custom headset. So that's the excitement for us, and I think that's all I have to say on the North Star. It's a good technology, and we're excited to be involved. Guys, thank you. Please follow the channel. We do those every week, and we'll have much more enterprise on the next one, and also a new AR headset that we're gonna present very soon. So Holographic Dreamer, thank you again, and have a great evening.